Welcome to my period 5 motivated students class. Everybody brought his book and his calculator and they're all totally involved in this lesson. And notice the x minus 6 is canceled. So you're left with y is equal to what? X plus 5, the graph of which is a line. So the question is the original function the same as y equals x plus 5? Are they the same function?
Yes.
Yeah.
Yes.
Well, not exactly. And why are they not exactly the same function? Anybody know? You can be on TV if you know the answer. Why is there a difference between function number 1 and function number 2? What's the domain of the top function?
All numbers
All
but
numbers but
6.
6.
All numbers except 6. What's the domain of the bottom function?
All numbers.
-5.
Huh?
Just all numbers.
All real numbers, because there's no restrictions on domain of...
-5
Yeah.
can be 0. Or does it really
It
matter?
doesn't matter. It's a polynomial.
Yeah.
So I claim domain of number 2 is what? All real numbers. Domain of number 1 is...
All numbers but 6.
So if you were to compare the graphs of those two functions, would they be the same?
No.
Well, here's the interesting thing. The graph of the rational function has a hole at x equals 6. Do that make sense? That is, since it's not defined at 6, I claim if I zoom in, I'm going to zoom in here. Now, we don't see a hole yet, do we? But I claim there's a hole. And why is there a hole? Because it's not defined at 6, but if I keep zooming in,
There's no hole.
I claim eventually, I'm zooming in tightly. Are folks excited about this? There's the hole.
Dun dun
Is that not amazing?
Someone just got proof wrong.
Now the deal is, if you graph the original function on your graphing calculator, you won't see the hole. Do you know why?
Because it's so small.
It's tiny, and if you think about it, the screen on the calculator is made up of pixels, and unless that hole lines up with a pixel, which it probably wouldn't, you would expect to see the hole.